Okay, hello guys, this is Kyle and this is Java tutorial, my first Java tutorial, and we're going to be we'll be looking at the event paradigm today. And it's also known as the observer pattern, and it's a pattern that is mostly used in object-oriented programming. The problem of object-oriented programming is that it fixes a lot of things. That's very convenient, but it also introduces some problems. And there's a major problem with object-oriented programming, which is that of component independence. When we are programming using the object-oriented paradigm, we always try to develop each one of our components independently of all the other components that exist in our system. So the problem is, how can we make each one of these components interact with each other? The event paradigm, which we'll be going through today, helps us solve that problem, because each class or component in our system can then throw an event, and anyone who is interested in that event may then watch out for that event. It may observe or listen for that event, and whenever that event happens, these other components may then react to it in whatever way they see fit. So in this slide, for example, we see that to implement the event paradigm, we need three things. The first thing we need is a listener interface. This is the object that is informed of an event whenever it occurs. Whoever implements the listener interface will also implement whatever happens whenever the event is thrown. The second thing we need is an event class. Now, technically it's optional, but we usually put it in because it's convenient for us to keep a reference to the event's source. You will see this later on in the example I have today for you. Okay, so the third thing we need is a source object. This is the most important of the three. A source object is responsible for registering listeners and firing events. Registering listeners means it keeps a list or set of listeners, and whenever it fires an event, the source will generate an event. It goes through this list of listeners and tells each one of these listeners that the event happened. As an example, in the standard Java, for example, the Swing GUI has a lot of this going on. For example, when you have a button, you can register listeners for it, so that whenever the user presses the button will then inform the listeners of what it will ask the listeners what to do. Very well. So today's example, which I'm going to show you, involves dogs. So I bet you animal lovers out there will like this. It involves dogs, and we will be modeling a dog's life. So we will have this dog class that generates events depending on what happened to the dog. So let's go to NetBeans here and create our example project. Now I want you to think a bit about what can happen to a dog. The things that a dog would need. So, and I can, for this example, I can think of four things, which you'll see right now. So the first thing that we said we need is a listener interface. So we create a Java interface, name it dog listener, and in this interface we will declare the methods which we think can happen to the dog. And the four things that I can think of right now are that it can get hungry. A dog can get hungry at any point in its life. It can get thirsty, It might feel lonely, maybe. And it can fall asleep. Very well. Now, as you can see, each one of these methods, I have added a dog event parameter. It's the event class that we mentioned back in the slide there. So you would tell me, why not create an event class for each of these 4 methods then? Why? Because the actual event is the method's name. Okay, so the event is that the dog is hungry, or that the dog is thirsty, or that the dog is lonely. This parameter here contains meta information about the event. For example, which we'll see the source dog that generated the event. You can think of it as the method name represents a variation of the dog event here. So the dog generated a dog event when he was hungry, generated the dog event because he was thirsty, etc. Now, something I want you to note is the naming convention. Usually, obviously, you can name things whatever you want, but usually what we do is, if we have a dog event, then its matching listener is a dog listener. If it's an action event, then the listener is action listener. If it's an item event, then the appropriate listener is item listener. And it's useful to keep to these conventions so that whoever is using your system immediately knows what each one of these classes does. Okay, now the next thing we need to create is the event class. So let's create a new class and name it dog event. Now, as I said, this is technically optional, but for convenience we usually want to keep a reference to whoever through the event, who generated the event. And as you can see, I'm going to add a reference to the source dog. This points to the dog that generated this event. This is extremely useful because then later on we can use the event class, the event object which we passed here, and use it to get a reference to the source dog. You can also add more information about your event here, and in the standard Java APIs, for example, in the Swing APIs, a mouse click event, a mouse event contains methods to the event contains methods to check which mouse button was clicked, whether it was the left one, whether it was the right one, and you can add all that type of information right here. But most importantly, for now, is the source. You almost always want to keep a reference to the source. And finally, we create the source object, the source class, which will be our actual dog. This is the actual business object, the actual dog. So, what did we say that an event class, that a source class should do? It has to register listeners. So let's create the collection for that. Here it is. It will be a set of dog listeners. For our example, we'll also give a name to our dogs. Here's the constructor. We shouldn't forget to initialize our set. Okay. Now, There are two ways of going about registering listeners, and I want you to decide which one is the best. So the first one is writing a method here that returns this set, and then the user can then use this set to add or remove his own listeners. Otherwise, we can create an add or remove method, which, given a dog listener, would either add the listener here or remove the listener from that set. Now, which one do you think is the most safe? Obviously the latter. Why? Because we don't want to give the user access to this set here, otherwise he could, I don't know, break it or something. So let's go ahead and create our add and remove methods. And a remove method there. If you've ever used Swing, I think you would find these methods familiar. Anyway, so two things to notice here is that these methods are synchronized in case we are using multiple threads. We don't want concurrent accesses to happen on the set. And the second thing, there was a reason why I chose set for the collection of listeners, and that is because here I now no longer need to check whether for duplicates, because the set automatically removes any duplicates for us. It doesn't make sense to have two listeners which are the same listener stored in the collection, so we use set to manage that for us itself. Okay, the second thing that source classes need to do is fire events. Now, we do this through fire methods, we call them, and we write them like this: fire something event. What each of these methods does is that it has to create an event object. So let's create it. Now look here, I passed a reference to this, to the constructor here, because this object is the source, and inform each listener of what, and tell each listener to run the appropriate to run the correct method there. As you can see, it's a protected method, and I've also added some output here so that later on we can see all this in action.